Welcome to Brain Vision.
So in this problem we have an elevator with a mass of 650 kilograms. We know it's starting from rest, so that means the initial velocity is 0. And once it accelerates, it gets to a cruising speed of 1.75 meters per second. So in order to get the average power, first I'll find the work done by the motor. And to get that, I can write out an energy equation. So I'll say the change in kinetic energy plus the change in potential energy is going to equal the work done by the motor. The change in kinetic energy is 1/2 times m times the change in velocity, so that's Vf squared minus V initial squared. The change in potential energy due to gravity is going to be mgh. And that's going to equal the work done by the motor. So this is going to be 1/2 times 650. Now, the initial velocity is 0, so that doesn't factor into this calculation at all, so we just need 1.75 squared plus 650 times 9.8 times, and we don't know the height. That's the only thing we need, is the height. So the easiest way to figure that out, I think, is just to write a couple kinematic equations. I'll do that over here on the side. So first I'm going to figure out the acceleration, because we know it's constant acceleration. So we know that the final velocity is the initial velocity plus the acceleration times time. We're also given that time is 3 seconds. So this is going to be 0 plus 3a. And so the acceleration is 0.583 meters per second squared. And now we want to find the height, so that's just delta y. And I'll do a similar equation, which is Vf squared equals V initial squared plus 2a times delta y. So this is going to be 1.75 squared equals, again, 0 squared plus 2 times 0.583 times delta y. So we get delta y is 2.625 meters. So we can plug that in here. Delta y is just the height because we're starting at height of 0, so the change in height is just the total height. And now we get the work done by the motor is 17,716.56. You get the point. Because now we're just going to divide by the time to get the power. So the power from the motor is the work divided by time. So we'll take this 17,716 divided by 3 seconds. We get the power is 5,905.52, and we're in joules per second, which is watts. This is in joules. Now, if we want to find the power when the motor, or when the elevator is at cruising speed, well, I think the easiest way to do this, I'm going to do a little differently, is using the force from the motor. And the force from the motor is just going to be, well, it has to balance out exactly with the weight, or the gravitational force. So it's just going to be mg, which is 650 times 9.8, which equals 6,370 newtons. And now instead of writing power as work divided by time, I'm going to write it as force times the velocity. So now we have the force is 6,370 newtons, and the velocity is 1.75 meters per second, because that's the final speed once it reaches the cruising speed. And this is 11,147.5 watts.